So let's find the local maximum and minimum values of this given function x square minus 4x plus 5. And in this example, we'll try to use the first derivative test to find the local maximum and minimum values of the function. So if you are not sure what first derivative test mean, then I encourage you to watch the suggested video. So let's try to use it. But as a summary, you know that the first derivative test says that if we need to find the critical number of the function. Okay, so at the critical number, if f prime changes the sign from positive to negative, then we'll have the local max. If the f prime changes the sign from negative to positive at the critical number, then we'll have the local mean. Okay, so if the f prime changes from positive to negative at the critical number, then it will be local max. If f prime changes from negative to positive at the critical number, then you will have the local mean. So we'll see that again, but right now you might have a sense that okay, to use the first derivative test, what do we need to do? We need to first find the critical number. So how do you find the critical number? Well, if you are not still sure that, then again watch the suggested video for finding the critical number of the function. Okay, so in this case I'm just trying to find the critical number by following a definition of that. The definition of the critical number is find first the first derivative, right? So which is on this case what it will be that, so f prime of x on this case will be just derivative of x square is 2x, derivative of the negative 4x is negative 4, derivative of the positive 5 is 0, so just 2x minus 5. So find the first derivative, and the definition of the critical number is see where the derivative does not exist. Okay, and the see where the derivative is 0. So in this case the derivative is 2x minus 4, so this exists everywhere, right? So we cannot find the critical number from that, but you can see here that we can check if the derivative is 0 at some x value, which we can actually do it by just setting the derivative is equal to 0. So let's just set this equal to 0 and then solve for x. When we do that, we get here add 4 on the both sides, so we get 2x equal to 4, and divide by 2 on the both sides, so we get 2x equal to 4 divided by 2, and that means x equal to 2 is the critical number, right, where the derivative was 0. So that's why it is a critical number. Okay, we find that. So now to check the sign of the f prime, because that's what we needed, we will create the sign chart of the f prime. Okay, so let's do that. How do you create the sign chart of f prime? We sign chart of f prime. So how do we do that? We need to know the domain of the function on this case, which is all real number, right, for the domain of x square minus 4x plus 5, and then see where f does not exist. Well, I mean, if this is the domain, then f exists everywhere, right? And see where f prime does not exist. There is no number like that. We have checked that earlier, but you can see here at x equal to 2 the derivative is 0, so we can use that number to actually partition the domain of the function. So let's write that down. Now choose some random number on the sub intervals from negative infinity to 2 and then 2 to infinity. Let's say 1 here, and then 3. Plug back in on the derivative, which is actually 2x minus 4, right? So when you plug 1 in, you get 2 minus 4, so we get negative sign for the f prime. And then when you plug 3 in, 3 times 2 is 6, 6 minus 4 is positive 2, so right, so we have the positive sign of the f prime. So I get this sign by plugging back this number in the derivative, and then see what is the number I get, positive number or negative number. Based on that, I was able to do this. All right, so now our goal is to use the first derivative test, right? So we have the critical number, which is 2. Now we see that at the critical number at this location, f prime, before that it was actually negative, right? Before that it was negative, but then actually it's actually changing the sign, and then by the increasing decreasing test you can see it is decreasing, here increasing. But the first derivative test is saying that if the sign changes from if the f prime changes its sign from negative, which is here, to positive, right, then f has a local minimum at the 2. So if that is the case, then we can just say that by the first derivative test, derivative test, f has local minimum, because the sign was changing from negative to positive, right? So local minimum at x equal to 2. All right, but do you know what is the, okay, we figure out that the local minimum exists at x equal to 2, but what is the local minimum value? How do you compute the value of the function? We just try to evaluate f of 2. So f of 2 on these cases, so this is our function, right? That is your function. So f of 2 will be 2 square minus 4 times 2 plus 5. So this is equal to 2 square is 4, 4 minus 8 will be negative 4, negative 4 plus 5 will be 1. So 1 is the local maximum value. Okay, local minimum value. I'll write down here local minimum value of the function. Okay, and if somebody is interested on local minimum point, then we know the x coordinate and y coordinate of the point, right? The local minimum exists at x equal to 2, so this is your x coordinate, and the value of the function at 2 is 1, which is the y coordinate of this point. Okay, this is how we can summarize the information.